Okay, so we have another example dealing with radicals. If we notice here, there is no number in our radicals, so we're working with square roots, and we also have a negative rational exponent. So negative exponent causes us to flip, and then we also have this radical, or the 1/2, so this is actually going to be 1 over the square root of 3x y squared times the square root of 54x cubed y cubed all over 1. And we just multiply like we would fractions. So let me go ahead and write this out here. And now we can actually reduce. So what's nice about this is if we can see any type of values that can be reduced in the radicals before we simplify, we can go ahead and do that. So I have a y cubed in the numerator and a y squared, so that changes to y. I have an x in the denominator and an x cubed in the numerator, so that's going to be square, so I reduce. 3 goes into 54, so if 3 goes into 54, we can go ahead and reduce that. And so we can go ahead and just reduce the 3 and the 54, which gives us 18. Okay, so now here's what I got left. Notice what was nice about this is everything in the bottom just canceled out. And so I'm left with the square root of 18x squared y. So I look at the 18, there's a 9 and a 2, a 3 and a 3. I'm looking for groups of 2. So then that means I can pull out a 3. I got a 2 left over on the inside. So I know I'm going to have a 2 left over on the inside. I know the y I can't do anything with, so it would just be y. And the x squared, the square root of x squared, is x. Okay, so whether it's a radical with a cube, a fourth, a second, whatever, the idea is going to be the same. We try and reduce. Notice I'm looking for 2 of the same because we're working with a square root. If it's a cube root, I'm looking for 3 of the same. If it's a fourth root, I'm looking for 4 of the same.